Hi guys. Today's lesson, I would like to just go over the most important vocabulary and do some more practice on Punnett squares. So what we have learned so far as vocabulary are the words dominant and recessive. We always show a dominant allele or letter in our gene pair with a capital letter. So here I have the example, capital B. And every time there is a dominant gene that's present, it will show in what we call the phenotype, the way it physically appears. So if we were talking about brown eyes and blue eyes being recessive, anytime one brown-eyed gene is present, it will show. Okay, think a dominant type of personality, kind of overpowering. Well, this is going to overpower a recessive. Recessive, okay, is going to be a lowercase letter. And so in this case, we use the same letter, and we're going to now show you a lowercase version to show it is recessive. So little b is going to represent blue eyes as a phenotype, and it's going to represent a recessive gene. Okay, so dominant versus recessive. Capital versus lowercase always shows, hides if there is a dominant present. Then we have homozygous and heterozygous. Homozygous means the same. Capital B is homozygous dominant. Lowercase b is homozygous recessive. The same. Two of the same. Another way of saying this is pure or purebred. Heterozygous, two different genes. Capital B, lowercase b. Okay, that's the only choice because we have two genes. Remember, this is focusing on one trait. In this case, we're looking at eye color. And so if I have the eye color, okay, brown is dominant over blue. Now we know there's many alleles that code for human eye color. Okay, it is not just one. So this is just looking at an example because you only have two alleles, one from each parent. So we only need two different choices, even though there are other choices in the world. Okay, there's green, there's hazel. That's not important here. We're only going to look at two alleles at a time based on the fact that that's how many you have from your parents. Now, dominant, so brown, and blue recessive, okay? The phenotype is how you physically appear. So if you have these genotypes, your gene pairs, remember you got one from each parent, and this is only on one trait. So if you have two capital Bs, it's always going to show brown eyes. If you have a brown-eyed gene and a blue-eyed gene, a dominant gene and a recessive gene, a heterozygous genotype, you will also have brown eyes. The same type of brown eyes that this person has. You're considered what we call a carrier for the recessive trait. That means you can pass it on to offspring, but you don't show it in your phenotype. You have no physical appearance of blue eyes. You can't look at somebody really close and say, I can see a little bit of blue eyes in there because you're carrying it. Okay, that's not how it works. So the only way to show a phenotype of something recessive, like blue eyes, phenotype is your physical appearance, is to have two recessive traits. Because remember, if there's a capital here, if there's a dominant, it will hide in recessive. So the only way to see it is if you only have two recessive, okay? All right, so when we use a Punnett square, the goal here is to create a mathematical way to look at what the proportion or the probability of offspring occurring between two parents. So what we do is we cross two parents that we know their genotype, their gene pair, and we then look at what the percentages could be of their offspring carrying or getting that disorder or getting that trait, whatever we're focusing on. So the only choices for percentages and probability are going to be 0, 25%, 50%, 75, or 100. You're never going to have a percentage that is in this strange number zone of, let's say, 33%. Okay, so as I'm going to draw my Punnett square, I just also want to mention there's also the ratio. So if it's one box out of the 4, it's 1/4, which is the same as 25%. If it's 2 out of 4 boxes, then that's going to give you your 50% or half. If it's 3 out of 4 boxes, that's 75. 4 out of 4 boxes is going to give you 100. 0 out of 4 boxes. Where do I get these 4 boxes? So the Punnett square that you draw, inside the box represents your possible offspring. So that's where I get the 4. I split it into 4 boxes. So this box represents one possibility, this box represents another possibility, this box represents a third possibility, and this box represents a 4th possibility. Outside the box, you will put your crosses, okay? So if I simply tell you that I have a homozygous dominant mother, say big B, and a heterozygous father, so that must be big B, little b, and I want to know the percentage of brown and blue-eyed children that are possible, what I would do is I carry this big B across, this big B across, this big B across, all coming from mom, and then I carry big B down, little b down, big B down, little b down, and I only now focus my information for my percentages on inside. This is my possible offspring. This was mom, this was dad. So this shows you what are the choices mom can give and dad can give. Mom can give and dad can give. Mom can give and dad can give. Dad's over here and mom's over here. Okay, that's where that comes from. Okay, so now I'm going to do the options. So what are the percentage I have brown-eyed children? Again, only in the boxes inside. This one's going to be brown because they have 2 dominant. Brown, brown, brown. Even though there's a little b here, somebody said, well, what about the little b here? This is a different box. So it has to be together. So this is going to be a hybrid or a heterozygous brown. So this is going to be 25, 50, 75, 100. 100%. Blue-eyed, remember that's only little b, little b. We have none of that. That's 0%. These are called phenotypic or phenotype ratios. How about having a homozygous dominant? That's big B, big B. Again, not the parents, the offspring. I have 1 here and I have 1 here. Okay? If I have 2 quarters, that's 50 cents. 50%. Little b, little b? No, 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 no. 0%. Hybrids, big B, little b, or heterozygous? 1, 2, 25, 50. This should equal 100% when you add it up. And this should equal 100% when you add it up, because it's all my choices. Okay? All right, let's do another one. This time, I'm going to give you the parents and ask that you figure out the Punnett square on your own. Okay? This time, we're going to do 2 hybrids, 2 heterozygous parents. Big B, little b, and big B, little b. Both parents have what color eyes? Brown. I want to know all the percentages for all my Punnett square. I'm going to put, doesn't matter where you put each parent, but I'm going to label this one mom just to keep me organized. Dad. Okay. Mom's genes are going to go here. Big B, little b. Dad's genes are going to go here. Big B, little b. Going to carry across. Big B, big B. These are for mom. Little b. I'm going to move it because I see that one coming down, and I like to keep it just like a capital name in your capital letter in your first name. You want to have the other one first. I'll move it. Big B from dad. Bring down the little b. Bring down the little b. Bring down the big B, which is why I moved that. Okay. How many of the children have brown eyes? Now I'm going to look at their phenotypes. Big B, big B. This one's going to be brown. Has 2 dominant. This one, all you need is 1. It's going to be brown. This one, brown. This one, blue. So it is 25, 50, 75% brown, And that's going to be that 25% blue possibility. And I'm going to go, how many of the offspring have big B, big B? That would be 1. 1 box, 1/4, 25. The same thing. They might ask you what the, in a ratio form or a fraction. How many homozygous recessive? 1. See no more. 25. You should hope that this answer is 50. Let's double check. 1, 2, like 2/4, 50 cents, 50%. Please don't think that that means they had 4 children. This is number child 1, child 2, child 3, child 4. Every time an offspring is checked, or every time they have an offspring, this percentage will happen. Okay, so it's the same thing for having boys versus girls. Okay, it's 50% chance every time that you have a boy or a girl. And I'm sure you know a family or two that have many of the same gender. Okay, I have 2 boys, even though I had a 50% chance of having each. So it doesn't mean if I had 4 children, I'd have exactly that ratio every single time you get a new chance. All right. All right. Hopefully that helped you with some of the percentages and looking at more practice with Punnett squares. Have a great day. Bye.